Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we'll talk about object literals, which will help us organize and simplify the JavaScript code that we write. Now, in JavaScript, an object is simply a structure with a open and closing curly brace and a name. And inside of there, we can define properties, which are like attributes or variables, as well as methods, which are simply functions that define some behavior. Okay. From that point on, those properties and methods function as a coherent unit. So this helps to collect related information and behavior together into one spot and then make it portable and reusable. Object literals are used everywhere in modern JavaScript development, and you'll see the structure that we're going to demonstrate often whenever you're doing software development, especially in jQuery with its plugins and passing in objects full of property settings that we want to configure the given plugin with. More on that later, okay? So here again, if you're coming from a different programming background, JavaScript has quite a different take on objects. In many programming languages, you create classes first, which are like blueprints for a data type. And then you create new instances of the class, and that produces an object. However, in JavaScript, there are no classes per se. You attach properties and methods to objects as needed. So if two or more objects need to support a given method, you can use the object's prototype to enable a form of inheritance. However, since this is a fundamental series, we're not going to be covering that topic because it's a bit more advanced. Traditionally, classes and objects are the basis for an object-oriented style of programming or approach. However, JavaScript lends itself to a more functional style over a true object-oriented style. So you may have to check your assumptions at the door on how things should work, even though you'll see some of the same sorts of terminology and even some of the same keywords used in JavaScript as used in Visual Basic, C# or some other programming language that you might be familiar with already. Okay, so just kind of pause any of your current thoughts about how objects are used, because chances are it'll be slightly different and you'll just start making assumptions that are not true if you follow along your previous experience and training in that regard. All right, so let's set up our examples. After a few examples, I think you'll get the hang of how things are different. So you can see that I've already taken the liberty of creating our HTML page. So I've used our template to create a new HTML page called c9js_12.html. You can see that I've already set the title and the H1 like usual. Here I've created, featuring the technique we demonstrated in the previous lesson, our reference to an external script that I called script12.js. And over here you can see I have script12.js already open and ready for us to start typing. So I'm going to assume that you've paused the video, that you've caught up, and that you are planning on following along, right? Okay, so here we go. We're going to create a very, very simple object literal to start off with one property and one method. All right, so it's as easy as that. We are creating a structure by defining an opening and closing curly brace and then setting our var called batwing. So the name of our object is batwing. It'll have one property and one method. The property we've defined is basically a variable, and inside of that variable we've initialized the value to ready. To separate one member of our object from another member of our object, we'll use the comma operator. So here we've defined a method that has been set. The body of the method is defined as an anonymous function. Inside of the anonymous function, we're merely using the document.write function to just print something to screen. All right, so now this is how we have created the object. What if we need to reference the values and the method of this object? Let's set up a simple example here. Notice that I'm starting by using the name of the object, then we're going to use this dot notation, which is the member accessor operator. So we want to access a member of our Batwing object, namely the status property. So if the Batwing status is ready, then we want to go ahead and rescue Batman. Simple as that. All in a day's work. All right, so let's go ahead and execute our application, and if I spelled everything correctly, it should work, and it does. It checked to see the status of the Batwing, and the Batwing was ready, and therefore it launched the rescue Batman method. Okay? All right, so let's create a second object literal. We're going to call this utilities. And it'll only support one method for now. And I just want to show that you can use an object as an input parameter to another function or method on another object. And in this case, what I'm going to do is take that target object and I'm going to loop through and look at all of its members, its properties, and its methods that have been defined. And so, when you have object literals in JavaScript, you can simply loop through all of the members of that object by just doing a for in statement. Then, once you want to get to one individual member, all you do, let's set it up a little bit here. I'm going to add a line break between them. All you do is just use target object and then use the index of the element or the item inside of that given object. So let's do this now. We're going to pass our Batwing object literal to the print all members method of our utilities object literal. And just because I don't need to see this again, I'm going to comment that part out. Save it. Now let's see if it runs. Hopefully I typed everything correctly. All right, so this is what we get. We have two entries here at the very top of our page because of the document.write just prints off, streams it out to the very top. Here we get the value of our first property inside of our Batwing object. The value is ready. And then we see the definition for the rescue Batman method of our Batwing. Notice it didn't execute it. We didn't ask it to execute it because we didn't use the execution operator. But it merely prints out its definition. Okay, that's kind of neat. So let's do one more thing here. I'm going to comment that out, and I'm going to just define an empty object literal. And then let's use our print all members to see if there's anything inside of it by default. And I wouldn't expect there to be, but let's just see what happens. All right, and there's not. But I think the moral of this story is that you can create an empty object literal and then later on attach properties and methods to it at some later point in time, and we'll demonstrate how to do that in just a moment. Let me comment that out. But in its simplest form, you can create an object literal with this syntax. Let's create a slightly more advanced example. Let's create a planet, let's say for like a game. And first of all, we'll create an ID. Notice I'm using a data type of number. Notice that I'm separating each of the members with a comma operator. Now this one is kind of interesting. What if I want to embed one object literal inside of another object literal? I can simply do it like this. Awesome. Okay. So here we have an object literal complete with 2 properties and 1 method, and it is defined as a property of another object. Cool. Something else that's kind of neat, a more complex version here, is any cities that are in this planet. I can use an array, and that array can contain other object literals. Now notice I didn't put these on separate lines because they're going to be so short. I can just inline them all like so. It's obvious to the eye what's going on here, I think, but you could separate them out on other lines and do indentation if you wanted to. All right, so we have a fairly complex object literal here. It has some simple properties, but then it also has some more complex properties, like a property that contains another object literal, as well as a property that contains an array of other object literals. Now, how do we get at some of that information? Well, let's do this. Let's see what we get printed out here. Make sure that nothing else is really going to stand in our way. Okay, and let's open that up. Great. So we were able to call the notification method of the faction object literal, which is merely a property of the planet object literal, by just using this member accessor notation. So we're able to chain these calls together. All right, let's do one more thing here. What about if we wanted to get to one of these cities? We would simply do this. All right, so notice the use of our index to access one element of the array which is a property of the planet object literal, in order to access one of its properties called name. And we were able to get it. Great. All right, and also then how would we set the values or change the values? Well, we can do this. So we have a before and after scenario, and we're going to rename the planet by merely accessing the name property and using the assignment operator to a new value. Let's go ahead and make sure we save everything, and let's go. So this is the before, and this is the after we've renamed it. Again, we would just use it like any other variable that we might be using. Let's go ahead and comment all that out. All right, so another interesting thing is that you can pass objects around by a reference to that object. So we can do something like this, var z equals planet. Now, z is a reference to our object literal. Therefore, we can do something like this, document dot write z dot name. And we get the name of our planet. All right, now let's suppose that we want to add a property or method that we're using our planet and we need to add an additional piece of information or another implementation of a method to this planet. Is this definition sealed? Can we add more information about a planet later on after it's originally been implemented? The answer is yes, we can. Now, we want to be careful about that because if we were to attempt to access, for example, the name, assuming that it didn't already have a name property, and we blow away the existing name, well, that would probably be some poor programming practices on our part. So what we need to do is use our type of operator again and see if, for example, let's say we want to create another property called defense. Is defense undefined? And in this case, notice that I've used the 2 equal operator. I think the 3 equal operator will work too. Let's go ahead and use that just to see. If not, then we can come back to it, because I think it returns the string undefined, so I think we're good. But here we want to now just start using a new variable called defense, or a new member called defense. We're going to set it to ion cannon, and then later on we will do a document.write planet.defense. Let's see if this works. And it does. Great. So here again, at any point in time, you can add additional members to object literals that have already been defined earlier in your code by merely just start referencing them. Of course, you want to be a little careful about referencing those that may have already been defined either here or in the code prior to the code that is running. So you want to do a check first. Has this already been defined? Oh, it hasn't? Then let's go ahead and define it. Otherwise, we might take some other step of logic, okay? And that's up to you to decide as the programmer. All right, another thing you can do is you can iterate through all of the members. And I think we've already shown that a little bit earlier with the use of our utility function, but I'm going to rewrite it in a slightly more interesting way. All right, so here we're just going to type in the name of the member and then let's see how this will different than the utility that we created a little bit earlier. All right, so in this case, you can see some something a bit different than we saw previously. We get the actual name of the property, or of if we were to have any methods defined, which we don't at the topmost level. But then also notice that when we do go to print out the value of this particular member, it's just of type object. And in this case, in the cities, it has 3 different objects all in an array. So that's an interesting side effect there. All right, just really academic more than anything else, I think, at this point. All right, but let me just kind of conclude that particular thought process by saying that you can use object literals, or you will use object literals often whenever you're working with JavaScript libraries. For example, one of my favorite JavaScript libraries is called the jQuery tools, and they produce a media player called Flow Player. And if you take a look inside of Flow Player, notice how you set some of the values. So let me go down. Here, this is how you reference or initialize the flow player object, by passing in an object literal. And so by understanding the syntax where, okay, we're going to set the clip to another object literal, an embedded object literal inside of that, where we're setting a property called autoplay to false, auto buffering to true, base URL to this, and so on. That is setting up the flow player to configure it so that it displays and it operates inside of the browser the way that you, the developer, want to use it. So the programmer who created Flow Player made all of these properties available. You pass in an object literal defining how you want to set up the Flow Player, and then it uses your settings and functions accordingly. Okay, so that's pretty neat, and you'll see that again very often whenever you're working with JavaScript or jQuery plugins. All right, let's move on to another idea here, and that is using the new operator. It's confusing whenever you see that JavaScript has a new operator, but it doesn't have the notion of classes. Typically, you would use the new operator to create a new instance of a given class in the computer's memory, and then you would initialize it afterwards. However, in JavaScript, the new operator creates an instance of a user-defined object type, or of one of the built-in objects that has a constructor function. So this is how it's used in JavaScript. Notice that we're starting off with a car, and we're going to allow the car to have a make, a model, and a year. All right, and then inside of this function, we'll say we want our car to have a make property, and so we'll assign it to the temporary variable of make that has been passed in to the constructor. And I just happen to name these exactly the same. I could say my make or temp make, temp model, temp year. So hopefully that doesn't throw you. But we'll show you how this manifests itself here in a second. Now I can create a new instance, I guess you would say, of the car, called my car, using the new keyword. Sorry. Let's fix that. Okay, there we go. Then we can reference those properties as you might expect. All right, so let's go ahead and save this. Great. And so I think the moral of the story there is that what you're doing is defining a constructor. And inside of that, you're defining the properties of an object by the same name as the constructor. When you use the new keyword, you're saying, I'm going to pass in arguments to the constructor so that we can create a new car object with its properties, make, model, and year set, so that we can then reference it later on. It's a slightly different way of thinking about objects. This isn't a class per se, it's a constructor. That's why it has the function keyword in front of it. Okay? All right, so much to take in, but I think the real important part of this is the construction and the use of object literals within JavaScript. JavaScript is a classless language, okay? It allows you to define, however, properties and methods and give them both the property and the value all in one context. You can then later on add or change the values like we did here, and you can also create constructors which set set the properties at the time of construction when using the new keyword. All right? So hopefully none of that blew you away. I wouldn't worry about that last part, a little bit more advanced. We're not going to use that very often, and you don't see it all that often in code either, at least the code that I'm familiar with. So, okay, very good. We're going to continue to build on this in the next lesson. We'll see you there. Thank you.